Okay, I'm Adam Galpin, I'm a psychologist, and I've been working with biomechanical engineers and another psychologist at Manchester University looking at the processes whereby amputees come to learn how to use their prosthetic arms. And one of the things that we've been considering is developing some kind of gaming application that would help them train to use their prosthesis. But we've been looking at upper limb amputees so far. So in this image we can see two amputees using different types of prosthetic devices, and what's useful to note in this image is that the concentration that's required of them to perform a fairly simple action, which is pass an object between them. We've been looking at transradial amputees, and these are amputees who have had their arm amputated below the elbow. And one of the devices, one of the prosthetic devices for transradial amputees is called a myoelectric prosthesis, which fits over their residual limb to replace the missing limb, and is controlled by electrodes that are placed next to the muscles on the remaining arm. And when these muscles are twitched, they create an electrical signal which controls the movement of the prosthetic arm, so opens and closes the grasp and rotates the wrist. One of the more advanced versions of these types of myoelectric prosthesis has gained some media coverage recently. It contains several different programs to allow different types of activities to be conducted, and so you can see this chap picking up a delicate object like an egg, and he's also able to touch type using a single finger. But despite the opportunity for enhanced functionality, lots of users of myoelectric prosthesis actually reject their prosthesis, so they stop using them. And it seems that the high rates of rejection are constant despite the fact that these devices are improving. And one of the reasons that we think that the amputees may be rejecting their prosthesis is because there's an increased reliance on vision, so there's a lack of feedback, haptic feedback, from the feel of objects as they reach for them. So they need their vision to control the movement of their arm in space and to know where their arm is. And we've actually in our studies studied this in the laboratory using gaze tracking. And we find that the amputees spend a lot more of their time paying attention to where their arm is, which means that their movements are very effortful. So one of the goals of the training is to make the movements more automatic and less effortful. And previous applications have tried to develop kind of a gaming environment to help train the prosthesis users to, for their actions to be more automatic. The gaming environments have tended so far to be quite simple and involve a virtual prosthesis on the screen, which the user will control with the same muscles that they would control the actual device. But what these gaming applications so far have tended to miss is the psychological aspects that make games really engaging, such as increasing the level of difficulty and rewarding the players when they achieve a certain level of mastery, and also getting this balance between level of mastery and challenge correct. And when this balance is achieved, the user is said to enter a state called flow, whereby they're fully concentrated and fully engaged and they lose track of time. And it's a very motivating state to be in. So one of the aims is to create a sense of flow in games. The games also, so far, have lacked any sort of narrative structure to frame the action. So there's no kind of story to the tasks that the user is required to make in the games. And such as our need for narrative structure, we sometimes impose it even when it's not there. So for me, in this simple tennis game, I always pretend I'm the underdog to give it a sense of meaning, even though actually, if you look at the scoreboard, I usually win. And another motivating feature of games is to develop a sense of competition. So if there's a community of players and a leaderboard, then users can use that to know how they're doing and to relate to other people, and this sense of competition is engaging and motivating. So far the games have lacked these psychological elements, and they also depend on a certain form of motor learning to teach these movement skills, and that's based on the accuracy of their movements, getting feedback on this accuracy and then attempting to repeat the movement again and increase the accuracy. But there are other ways that people can learn how to produce skilled movements, and one of them is through imitation or observational learning. And studies of prosthesis users suggest that they actually imitate and learn better from other prosthesis users. So the model here would perform an action, and the person learning the action would attempt to imitate it, and that's better when it's a prosthesis user. It's also better if the model adopts the same perspective as the person attempting to imitate the action. So the egocentric view here on the right, because this allows a better mapping between the body position of the person attempting to do the movement and the body position of the person modelling the movement. And the other factor is whether the movement is transient, so directed towards an object, or intransient, where there's no object involved, such as a gesture. And it seems that intransient actions require more attention and thus may be better candidates for teaching fine motor coordination. So, the idea we're considering is bringing all these elements together into a gaming application that's based on a kind of imitation type game, whereby a virtual prosthesis user will perform actions on the screen and the actual prosthesis user will attempt to produce those actions. And what we would like to do is bring in those elements from the psychology literature about what makes games motivating to make this more than just a simple training tool, but actually something that's enjoyable and engaging in its own right, to encourage the prosthesis user to persevere with the application. So it's probably worth pointing out that none of the people involved in the project so far actually have a background in developing games. So what we really hope by bringing this here is to get some feedback on how these sorts of ideas could be instantiated into an engaging and useful application. Thank you.